Hey guys, going on to example 3 here for lesson 3, 4. So monolith mathematics. So now we're just going to look at it, and I really like this problem a lot because hopefully this makes everything make sense. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. The tables come in 2 different sizes. The small table seats 6 people. The large table seats 10 people. So now we have an equation, 6x plus 10y equals 180. Make sure, whenever you get these equations, make sure you understand what they mean. 6x. Well, if 6 people can sit per table, 6 per table. That's the total number of people at that table. 6 times the number of tables. So we have the number of people at the small table plus the number of people at the large table. And we want that to equal 180. Why? Because we have to have enough seats for 180 people. So it should make sense. The number of people at the small table, the number of people at the large table will be all the people we need, which is 180. So how do we get that? 6 times the number of small tables is the number of people sitting at the small table, plus 10 times the number of large tables equals 180 total people. So now we know x must represent the number of small tables. Y represents the number of large tables. So now we're going to graph the equation, interpret the intercepts, and find 4 possible solutions. So the first thing I want to do is just find the intercepts, okay? So to do that, I'm actually going to turn the lights on here for a minute and just cover this up because we don't need the problem for this. We're just going to work this out. So to find the x-intercept, we know something at the x-intercept. At the x-intercept, y equals 0. Never, ever forget that. So you could use cover-up method, which you cover this up, and we have the equation 6x equals 180. Or you can just remember to plug it in. 6x plus 10 times 0 equals 180. That's going to drop out. So we're at that 6x equals 180 anyways. Divide each side by 6. Then we're at x equals 30. So the x-intercept, we have our first point. So the x-intercept is at 30, 0. The y-intercept. Again, you can use cover-up method, cover up the x, and then you'll get the equation for the y. Or you can just remember, x must equal 0. So you're at 6 times 0 plus 10y equals 180. That goes to 0. 10y equals 180. Divide both sides by 10 to get y by itself. And you're at y equals 18. So our y-intercept must be the point 0, 18. Now, I want to make sure this makes sense. The x-intercept said y must be 0. But the y represents the number of large tables. So when we look at our x-intercept, all this means is we can seat enough people if we have 30 small tables and 0 large tables. We have to really get comfortable with what that means. We're talking about intercepts, we're talking about points. Each individual part of the point, each coordinate means something. This is the number of x's, this is the number of y's. For us, x meant small tables. So I have 30 small tables and 0 large tables. Take a second and say what you think the y-intercept should be. So 0 small tables and 18 large tables. And this is why we graph, this is why we do this. That's a lot of information to just put in a very easy point. Now let's go back to our graph. So now that we have all the information set up, all I'm going to do is use the information up top and graph our line. And then we're going to see the power of graphing. So I know this is going to be a little bit difficult to see. I'll turn the lights back off. But on your paper, you should be able to see these all go up by ones. So it goes from 0 to 30 and 0 to 20. Okay? But we're going to plot our two intercepts. Our y-intercept is 0, 18. So we go all the way up to 18. Then I'm going to go all the way over to 30. And I need to make this as straight a line as possible. This is not going to be that easy because I made this so big so you can see it. Typically, your ruler is big enough to cover your graph. I feel like mine is going to be a little off. Mine is way off. Sorry about that. Let's try this again. That one looks better. So remember what a graph is. A graph is a pictorial representation of every possible solution. So one thing we need to remember about this, which we didn't talk about in the beginning, does every number work? In other words, do we have a discrete or a continuous graph? I drew a continuous graph just because it was easier for me to draw. But I need to remember, not every point is going to work. I can't have half a table. So these points work. I can have 18 and 30. I can have 18 large tables, 0 small. I can have 30 small tables, 0 large. Those numbers make sense.